Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. Okay. Well, welcome everyone. Today we have with us Rúnar, who is one of the founders of the Unision programming language and also wrote the Red Book, the Scholar Red Book.
Which I did read this summer, and it took me a long time, and there were examples that I just had to stare at for a long time. I feel like, and I got all the way to the end, but I feel like I got about 30%, which was helpful. You know, it moved me forward.
Did you have to hold the book to your face so it would absorb? The code would just absorb into you?
There was a lot of just staring. There was, you guys did some clever, you had some clever code in there.
Oh, so, I'm sorry.
Well, welcome, Rúnar. It's good to have you on.
Thank you. It's good to be on here.
So we have talked a number of times in the podcast about Unision, and we both just have a little bit of experience with it. We've done some hackathons at some of the Crested Butte conferences with Unision. I don't think you participated.
I did not participate in those. No.
That was the main time when I got my hands into Unision, and but I'd love to hear, what is Unision? We've mentioned it a lot of times, but what is it, and why does it exist?
Does it exist?
Does it exist?
Good question. Well, so Unision is a programming language. It is a general purpose, purely functional language. It's strictly evaluated, kind of like Scala. It looks syntactically very similar to Haskell. And the key feature of it is that it's content addressed. So that means that, when you create a definition, like a function or a type, the name of it actually is canonical and based on the definition itself. So it's a hash of the definition. So everything
the definition is not the code necessarily. It's more like the AST of the definition or something.
Right. So code in Unision is not text. It's stored as a tree. And the text is simply a user interface onto the tree. And then we store the tree in a binary format in a database.
So if you change the name of something, that's not necessarily changing the hash of the function, like something within the function.
Right.
If I rename a value or...
Right. The hash of a function never changes, so it's based on the implementation after all the names have been removed. And so if you change the name of anything, then that just adds metadata to the database saying hey, this tree now has this name. And
but so the actual functionality hasn't changed in any way, so it's still the same function.
Right. So it's a trivial operation to rename something. And
refactoring
I was working on
easy. That'd be nice.
I was working on a doc yesterday. I was just working on documentation in Unision, which is written in Unision. So there's a documentation sort of special syntax. So it's just a Unision data structure. And I was using I was referencing something, and I reference it by name because that's in my code base, in my database. And then I realized that later I might have to change the name of this thing. And I was like, oh, that's totally fine. All my docs will be updated. Automatically.
So there's this automatic reaction oh, I can't rename that because it's going to cause all this pain. And then you're like, oh no, I'm in Unision, and that's easy.
So you're basically separating the information about the code from the meaning of the code. In other words, the AST is what the code means, and the metadata is the extra
what the human needs.
Basically human description of what it needs.
Yeah, there's a number of things that sort of fall out of this fact that every Unision definition has this canonical address in the global address space. And it
global, you mean global.
You mean the whole world.
Yeah, I mean it's a given Unision definition will always have that hash, no matter who writes it. And then, when you share code, you share the hash as well as the implementation, and that implementation will have the same hash at every place.
So if I write a function that takes two integers and adds them together and returns it, anyone else who writes that same function, will have the same hash, and so we're sharing the same hash. Like it doesn't matter who writes it.
Right.
In the global space, it's the same thing.
I mean, you might use like different local variable names, and you might give it a different name or something, but Unison will see it as the exact same thing. Like for instance,
if the functionality is the same.
If the functionality is exactly the same, like if the implementation is exactly the same. For example, many people might write like the option data type or like the maybe type, and they might call it different things, and the constructors might be in different order or something. But Unison will see it as not just like compatible types with different names; it'll see it as the exact same type, and the type checker will actually unify those things.
Whoa.
So what problems are you trying to solve with this new approach? I mean, you wrote this book in Scala, and I'm guessing that at some point you said Scala isn't enough. It's not solving all the problems we need to solve. So what new problems are you wanting to solve with this?
Well, yeah, the Unison language is supposed to solve. Well, it's kind of just like a new approach to the whole developer experience of writing software. So we've been sort of stuck with this sort of textual representation, where we're mutating bags of text files. We've been kind of stuck with that, since
the
like the 60s or something.
Yeah.
Or even before, but like that paradigm, you end up running into walls with that, and I think that those walls, we start to sort of take them for granted. But like the program text of of the source code is really only just like one aspect of like writing software. There's all this other stuff, which is like version control and collaboration. And like version control doesn't really currently understand anything about the code. It just, it just understands that you have a bunch of text files. It doesn't know what the contents mean.
It drives me crazy when you like, all you do is run a formatter. You've changed nothing about the code, and all of a sudden you have like all these changes in your code. It's like,
so you don't want to run the formatter because
it's like, I don't want a commit that just has these changes that didn't actually really change anything.
Exactly.
And that's one of the magic tricks that you can do with Unison, is that when you open code in your IDE, it takes that representation and turns it into the visual form for you. But you can apply whatever formatting you want to that, and it's not actually changing the underlying code.
So if I wanted to use tabs instead of spaces,
right?
It doesn't care.
Actually, Unison will just forget whether you use tabs or spaces.
Right, because that's not part of the AST.
Right. So the actual source code that you write, it gets thrown away. Mm-hmm. And so it doesn't actually get saved into the database.
So when you reopen whatever representation, it recreates the code from the AST. And then how does it apply? How does it know how the metadata should appear? Because presumably like comments and things, that's not part of the AST.
Well, yeah, it actually, so comments, there's a number of ways that you can do comments in Unison. Like you can do comments that are just sort of for you, where they get ignored when the code is parsed. And there are also this sort of inline comments, which you can just use strings for. And so they become part of the AST, but they don't actually execute when you run. So yeah, they actually do become part of the AST.
Okay. But the inline comments, those are stored in the metadata?
At the moment, no. I mean, comments are not part of that metadata format, but things like names become part of the metadata, and like authorship and licenses and other things like that get stored as metadata on um, on that syntax tree.
So when I reopen this code, the AST produces something that I see, and then the metadata is somehow
render it as source code for you.
Yes.
And what you'll see is it'll use all of the local variable names that you used, and it'll use the name that you originally wrote the function in.
And it's pulling that from the metadata as well.
Right.
So somehow it combines the AST and the metadata to give me the representation.
And with a code formatter that could be...
Right, could be anything.
Could be anything.
Right.
Yeah. So currently there's only one surface syntax for Unison, which looks a lot like Haskell. But theoretically, we could have multiple surface syntax renderers. So, you could be looking at code and writing code that looks like Python or Lisp, and then I can be writing code that looks like Haskell or Scala, but we're both writing Unison code.
Huh. Oh, so I could actually, if I'm like super comfortable with Python, I could actually write my code in sort of a Pythonic way.
Right.
Huh. That's
wild.
And then when I look at it, I'll see something that looks more like Haskell.
Okay.
So that's kind of cool.
So you said at some point we need to rethink some of the very foundational pieces of programming languages, and you and Paul were the main creators. Is that right? Paul Chisano?
Well, Paul Chisano is the instigator of this whole idea. But yeah, so Paul and myself and Arya Irani, we started a company around this called Unison Computing.
So one of the foundations that this addresses is something that we run into a lot in the non-Unison world, which is upgrading libraries, and it's just is such a huge pain where now the Java has the module system to deal with, how you can kind of sandbox and namespace things. And I don't know, you know more about the module system than I do.
Not really sure that was even the problem it was trying to solve. I think it was really more their internal issue, because you don't have to use modules, and I'm not even sure how much benefit you get unless your project is a big library.
Right. But this was like bolted on after the fact.
Yeah.
And I think when you see it bolted on, you're like, I don't know, this idea of modules or whatever the need is underneath that really needs to be something that's thought about at the beginning.
And in terms of version control, which they didn't in Java. They just said, oh, we're not doing that. That's Gradle will take care of that. Yeah. So, but I think it does need to be, because we see these issues in Python and then of course in older languages too. So.
Yeah. So with like Unison and this AST approach, doesn't it make the compatibility issues across libraries or whatever you call them in Unison? Doesn't it kind of change the paradigm around that too?
Yeah, I mean, it makes it completely different. You still do have like version management issues, and you still have sort of inherent problems with that. But you don't have this issue, for instance, where like you have a dependency conflict. For instance, in Scala, where you might have library A and library B that both depend on library C, and they depend on different versions of library C. And now you can't build your project because, like, those two things can't exist at the same time.
Right, because you can only have one version of library C.
Right, but in Unison, you can actually have all the versions. You can have all the versions simultaneously in your code base, and it's perfectly fine, because if they really are different, then data types will have different hashes, functions will have different hashes, and then you can mediate between different versions of things with ordinary functions. If you try to pass off one version of a data type as another, like you try to pass it to a function that accepts like a later version of that same data type, you'll just get a regular type error in Unison. And so another consequence of this code base thing and everything being content addressed is that we don't actually have builds. There's no compilation step. Everything is stored in this AST, and it's sort of compiled just in time to like a bytecode format. But it's there's never a time where you take my entire code base and now like compile it or like do this build against all of my dependencies. The code base at any given time is built and works, and so you make these sort of incremental changes to things.
So as soon as you type some code, the compiler or whatever turns it into the AST and stores that AST, but then you don't.
None of the other code has changed, so there's no reason to compile it.
Well, and if you share that with somebody, you're sharing with them the AST, essentially what I think of as like a class file, essentially, but they don't need to then recreate that class file because they already have the AST form of it. Is that all accurate?
Exactly.
You said it was going into some kind of bytecode format. Is this what does Unison run on?
Unison runs on the Unison runtime, which is just our implementation. It's a virtual machine that just runs Unison. It takes the Unison AST, it compiles it to an intermediate form, which is kind of like a bytecode, and then it runs it on a bytecode interpreter similar to the Java virtual machine.
Okay, and this what platforms is it available on now?
At the moment, it runs on Unixes, so it runs on Mac and Linux and things like that. We've been trying to implement Windows support, but there's been some difficulty in like actually getting it built. It's written in Haskell, and we've had some issues with compiling Haskell on Windows.
Interesting. I was going to ask you if Unison was like self-hosted yet.
No. It's
all in Unison.
Both the compiler or type checker and the the tool as well as the runtime are written in Haskell, and we actually piggyback on the Haskell runtime.
Interesting.
For running our bytecode interpreter.
Do you see at some point self-hosting it?
Sure. Yeah. There's no reason we couldn't do that.
Probably a lot of work.
It's a lot of work, and it's kind of on the back burner for now.
Sure.
Yeah.
You're just.
But before we get to like self-hosted, where like Unison is written in Unison, we can get a lot of benefit from giving people an API where they can talk to their code base through Unison. So you could interrogate your code database from your Unison programs, and we can get there a lot faster than we can get to like actually writing Unison, writing the tool in Unison.
Sure.
Yeah. So one of the other magic tricks that you can do with this setup that I've heard you talk about is the ability where, because you're pure functional and you have the hash of a function, globally, if a function is called with a given parameter, you globally only really ever need to do that once. Like once you compute the output, once someone has computed the output, then you never need to recompute that. Is that accurate from what I think
that's right. So once a given hash has been called with some arguments, it never actually needs to be called again with those arguments, technically. And we take advantage of that with testing. So if you write a test in Unison, you add it to your code base, it runs the test, and then it stores the result. And then, you don't have to like rerun your tests like as part of a build.
So it's basically built-in memoization.
Yeah, but it's more It's also for collaboration. So like if I write a library and I write my tests and then I publish my library, I also publish all of my test results so that you can see that the library works without having to actually run the tests.
And so much computing power is wasted because some developer pulls down a code base and runs the tests, or some CI system runs the tests, and it just is every person and every CI system is constantly redoing the same work. And in Unison, you ideally there's never any duplication of work of recomputing a given function.
Only if you change the code that's being tested.
Or the inputs change in some way.
Right.
Yeah.
Mm-hmm. Yeah,
it'd be
ideally.
interesting to calculate like how much computing power is just wasted on doing the same computations over and over globally.
Yeah, like probably. Running builds, like there's so much computing power being wasted on running builds where you're just like, oh, I changed some comment somewhere or something, and now continuous integration needs to run the whole build over again.
Yeah, it just wastes time too, because there's the time to get to verify that a change is good and run it through your whole CI process before you can deploy it. For a lot of systems, this takes like monumental amounts of time, like hours, potentially days.
Well,
in some
plus
cases.
There's the psychological, once your brain has to wait for more than a couple of seconds, it starts wandering off. And that instant feedback that you can get from a very fast system. You're too young to remember this, but back in the early days when we had CPM machines, this was the first thing that Anders Heilsberg did, he created Turbo Pascal. And
Rúnar is an old Pascal developer. I remember from
Turbo Pascal is my native language, basically.
Is it really? Okay, because on a CPM machine, like we had to, go through all these compile steps, and when you had this environment where it was just like you do something and it was instant, it was like revolutionary. It was so huge, and you're basically recreating that experience in some ways. That
recreating it globally.
You're recreating it globally, right? Yeah. How does that work?
And also more than that, we want to take advantage of this when it comes to distributed computing, and that's really where we think Unison is going to come into its own. It's where you can have multiple computers running Unison, on a network. And then you can have them all running different parts of your Unison program. So you can write a distributed program in such a way that you can ask one node, hey, execute this hash. And that other node will either say, this is sort of simplified, but the other node will either say, yes, okay, I know what this hash is. I'm going to go run it. Or tell me what the implementation of the hash is, and then I'll run it. And so then you can write distributed programs in much the same way as you would write non-distributed programs. And so then the sort of transfer of control between nodes is really just like, oh, take this closure and run it over here.
Yeah. And you can let the distributed runtime make the decisions around when and where things should be run. Whether they should be done locally on the same node that needs it, or distributed out to another node.
It seems
that's actually the thing, that we don't actually want to have our distributed runtime. The thing that we want to have is just like the local runtime, but it's going to be completely a library concern where to run things.
Yeah.
So then that's completely within the programmer control. So you'll have this abstract notion of a location. And then you can say, like, at this location, run this closure.
Yeah.
So it seems like that would also affect just local concurrency, parallelism kinds of things. If you could say, well, run this on this core or that core.
I don't see why not. You could definitely have an implementation of that library that would, distribute your... that's certainly a valid implementation of it. Or you have something that just runs everything locally on different cores, and you might even have different locations where you can control very tightly where things get run on your own computer.
Right. It could either be local or distributed, and maybe that would be transparent or have a certain level of transparency to the
Like level
program.
1 distributed is on a different CPU. Level 2 is on a different process. Level 3 is on a different network node or something.
Well, in practice, you usually want to run computations close to the data where that it's computing on. And so, normally you'll have something like, you'll be running an AWS and you'll have something in an S3 bucket that is in a particular place. And so then, you'll want
close to that data.
Yeah. So you will have some location that is close to that data, like in the same region of the cloud. And then you say, execute this there.
But maybe if there was some characteristic like, oh, well, this requires a database and that's on another machine, then it would say, oh, okay, then we'll run it over there.
Yeah, I think the meta topic is that data is hard to distribute. Compute is easy. So let's make it easy to move the compute to the data.
Right. I guess that's traditional setup. Well, Spark. So the traditional Spark setup is like, okay, you set up this sort of Spark cluster, right? And then you have to sort of like distribute your program to all of the places where it's going to run.
Yeah.
And that has to be done beforehand. Like there has to be like a deployment, and then you go and like execute your jobs on the Spark cluster. But with Unison, you should be able to do this very programmatically. So you run your Unison cluster once and for all, or you purchase access to a Unison cloud that someone else has set up. And then just as a library call, you say, I want to execute this code that I have here on a particular region of that cloud.
Yeah.
And so you never have to like build your code and deploy it to this Unison, to the nodes. Yeah. You just
and then deal with versioning, right? Running. Like, because then whenever there's that whole concept of building and deploying, then you have to think about versioning and how you version schemas and how you deal with different versions running in different places and the interoperability between those, and all those problems just magically go away.
Well, they don't magically go away, but
I guess when you have external schemas, you still have to deal with
yes,
that. But at least definitely. When you're in the Unison application tier, you don't have to deal with them there.
So what do you don't necessarily have to have this happen, but often something that moves a language into the mainstream is the so-called killer app kind of thing. Do you have any thoughts as to what that might be? Like somebody comes across this and they go, wow, I am 10 times more productive or less costly or whatever because by switching to this. And so absolutely, we're going to do it.
Yes, I think that distributed computing and cloud computing is going to be that killer app.
Okay.
Because
microservices are really freaking hard.
Microservices are really hard. Spark clusters are hard. Like you can have a job being a Spark cluster administrator, right? I mean, that can be like a person's full-time job, and that person gets paid like hundreds of thousands of dollars a year. And more than that, just like maintaining the sort of the ops, maintaining like a cluster that you're going to run. Like even if you're not doing like Spark, like to say you're doing microservices and then just like doing ops on a system that has like, thousands of services or something. That's really complicated. And it's a highly specialized skill that commands really big salaries. And so it's like, what we want to do is simplify that by the only thing that you're actually going to be running is Unison, and then you just have the sort of ops part of things kind of under programmer control, right? Where you say where you want to run things. So I guess it's to kind of like contrast with like the way that you traditionally deploy. In Unison, you kind of like you deploy just in time. So like you, instead of like describing your deployment out of band by some other tech, like a bunch of YAML files and you know,
Yeah, it's like we've separated these concerns of like the deployment descriptor, the instructions essentially for how to do the deployment, and the actual compiled code or whatever.
Yeah, and like none of that stuff is like written in a programming language, and it's often super brittle and it's difficult to maintain.
Yes.
And it has to be versioned and all kinds of stuff. Whereas in Unison, you just deploy the program by running it.
Sounds like magic.
And the deployment is like written in Unison, and there's no build. There's like no build deploy cycle, and that's like managed by even more tech, like there's CI and Travis and whatever.
Yeah.
And so we just want to get rid of.
We've built up all these layers to work around the way that we have essentially constructed for what it means to be a program and how to run it.
Yeah, it's like we've built up this whole tower of technologies for like just how to like run a program on a bunch of computers. And I think it's mostly because in traditional programming languages, a program just describes the single OS process, and then any communication among processes has to be done over some kind of protocol or described out of band, by some technology that isn't like built into the language, or isn't library code,
Yeah.
It always seems to end up being a scaling issue. It's like we start out, we go, oh, I can write a C program, I can compile it, I can give it to the customer, they can run it, cool. And then we start adding more and more requirements, and then it's like, oh no, this is starting to fall down, so I need more tools, we need to add more tools, and pretty soon we end up with a whole bunch of messy things, and we're wasting a huge amount of time.
Yeah, you run up against this really quickly. Like, let's say you're a data scientist or something, and like you make some kind of model, and you're running it on your machine, and you're like, oh, this is great. But now I want to take this and I want to run some tests on it. And so, I need a cluster with like 5,000 machines in it or something. Okay, well, now this is like a problem that I need to go and take to IT or something, and I need to get like resources to do this. I need to talk to the people who manage the ops for my organization, and I like need to get permission, and I need to, it's like a completely different.
They need to build the infrastructure and give you all these different policy-driven ways to allow you to do what you need to do, but make sure you can't do things you're not supposed to do, and
right. And it's like, oh, does this need to be monitored? Is it like mission critical?
Yeah, then you have the whole ops SRE like side of things and
all kinds of stuff.
Yeah.
But with Unison, what's really striking is that you can take a program that that runs on your local machine and just tweak it a little bit, and then it becomes a program that can run on any number of machines.
Yeah.
And so as long as you have access to a Unison cluster, we're going to end up building this ourselves. We're going to have this thing we're calling the Unison Cloud. And so you'll just have an API key and a library, a Unison Cloud library, and you'll just make a library call to execute your Unison code on our cloud.
Nice. And it's just a matter of executing the code. It's not a CI/CD process that you have to define and maintain and all that. You just call this library and
you just like tell it where's your S3 bucket, and like,
Yeah.
tell me where this thing is, and I'll execute your code.
So you said you're creating your own cluster. Is that your are you talking about building physical machines, or are you talking about a cluster in the, I don't know, Amazon cloud?
Yeah, I mean, right now we're looking at building things in like already, we're hosting them in other people's clouds, like Amazon and Google and DigitalOcean and Azure and those places.
Okay. Yeah.
But I think the main thing is that it really shouldn't matter like where we're running.
Right.
So I guess in a way we want to be like cloud agnostic or something.
Yeah.
Oh, sure.
Putting that in scare quotes.
Mm-hmm.
So I want to talk about effects.
Okay.
Ready to go into effects?
I think so. Yes. Oh, well, actually, do you have any current, I don't know what, I mean, I'm trying to get a sense of where you are in this whole process. Like, do you have any trial customers that you're building systems for using Unison, or are you not there yet, or what? Like, if people are curious,
we're not there yet. The Unison language is in alpha. I mean, it's alpha quality software at the moment. There are a lot of bugs, a lot of stuff that isn't implemented or is sort of like preliminary. But it's, you can already like write Unison code, and you can write libraries in Unison and share them around. And we have a growing and friendly community of people writing Unison code. And
what was there was something that you or Paul added just in the last couple of weeks that I think I remembered seeing the tweets. It was like, you're really surprised by how easy Unison made adding this new feature or building this new thing on top of it. I don't know if it was like a documentation tool or what. Does that ring a bell for what?
Yeah, one of the things is that documentation in Unison. So Unison docs are written in Unison, and I don't remember what specific thing you're talking about.
I don't remember the specifics, but I remember there was just, you were like, oh, like this was, you or Paul were like, oh, this was surprisingly easier than I thought it would be to add this new feature. And it was, I'll have to look up what that was.
I think it may have been converting between versions of documentation formats. So like we upgraded the documentation. It goes through revisions.
Yeah.
And then for converting from one version to another is just a simple function in Unison.
Right.
So then you can actually just compute the new format from the old one.
That's cool. Yeah. So let's talk about, so I guess to recap that one, people can get Unison. I've downloaded it, and it comes with its own like IDE experience, right? Was there an IDE, or was it
of sorts? I mean, we have this thing called Unison Codebase Manager. So it's a command line tool that allows you to interact with your codebase, and then you just use your favorite text editor to write your actual code.
Yeah.
And it works in such a way that like you work in just basically one buffer in your code in your editor, and then when you save your buffer, the tool automatically detects that and like tries to make sense of your code. And it's a very interactive experience.
What editor do you use, or which one would you recommend people to start with?
I mean, I use VI. That's just me.
Well, okay.
A bunch of us are using Emacs. Others are using VS Code.
Yeah. Okay. So, all right. So it works with VS Code, not IntelliJ?
You can use IntelliJ. That's totally fine.
Okay. All right. No, I'm just wondering if there's any sort of interactivity that one might get from a particular
The interactivity
editor.
comes from the command line tool. And then there's also a graphical interface just for sort of browsing the code. So you can have the tool open a browser. So it serves an HTTP server where you can browse through your code base.
Mm-hmm.
And
that's what I remember.
Beautiful JavaScript and HTML.
Nice.
Okay.
So effects. So we've been writing this book on effect-oriented programming using Scala and Zio, and our I'm pretty enamored with the idea of effects. I think you've probably been in that world long before I entered into it a few years ago with Zio. Um, but it seems like there's kind of a big shift happening around effects, and Zio being the like monadic Scala way to do it. But Unison is taking a different approach, I think, which is algebraic effects. Am I getting that right?
Yeah, so we're using this technique called algebraic effects. We're calling them abilities. So it's based on a language called Frank from a paper called Doobie Doobie Doo, and
Nice.
it's which is a pun. It's a great paper. You should read it. It's very short,
Okay.
but it's yeah. So that paper calls them abilities, and so we're calling them that too.
Okay.
And so it's a lot like free monads, if you're familiar with that from Scala.
Yeah.
So it works very similarly.
Okay.
But the user interface to it is that it looks like imperative code. And there's no difference really between calling effectful code and calling non-effectful code syntactically.
Huh. How is that
So
possible?
How is that possible?
Yeah.
Well, we just make the type checker smart enough to
So the type
figure
checker
out.
knows that something is an ability and then can do special things with it.
Yeah, so certain functions will require certain abilities. So for instance, like a print line function, it takes a string and it returns unit, but it requires the ability to print onto the console. And so something will have to provide that ability. So there are ability handlers where you can provide abilities. But for things like print line and for things like I/O, that ability is actually provided by the runtime. So like where there's an entry point into your program, you can, if you have a main and you run your main using the runtime, it gets provided the I/O ability.
The default environment. Yeah.
But like you won't be able to call print line from a function that doesn't have the ability to do I/O. So from like a pure function.
Yeah. Okay.
Right.
So you could define a function that would require that ability, and then you could call printline, but it, like that, the abilities propagate through all the call.
Right. So they have to be provided somewhere in an outer scope, and then once they're provided, everything that's called inside of it has the capability of using that ability. And then certain functions will require certain abilities, and they can use them as long as they're provided.
Huh.
Sounds kind of similar to the way Zio works.
Yeah.
I mean, because in that signature you've got it kind of. Anyway, It seems kind of similar.
I mean, it's pretty similar to like monadic code, where a function will have, it'd be a function from A to B, and it will require, it will have some effect M, like some monadic effect M. So it's a function from A to M of B, right?
Yeah.
And so then something, in order to like get at that A, or in order to sort of like eliminate that M, something will have to like tell you what is the implementation of M? How do you actually run one of those M's?
Yeah.
For example, with like a state monad or something, you'll have to give it the initial state, calling something like run state or something to get your state machine to execute.
Yeah.
But in Unison, that's like not. So it's still part of the type signature, like the effects are part of the type signature. So like if you had something like a state ability, like the ability to get and set some state, global or like global to you state, you will be using something like an ability called store. And so then you say, oh, I want to store this thing in my state. And then now your function requires the store ability. And then now your function will be not from A to B, but from A to B with this little squiggly effect thing on it. It's a different kind of arrow.
And so you're in Unison, you have syntax essentially that talks about the abilities or expresses the abilities that something needs. And
in
it's
the types.
It's in the, and is it in like generic parameters on the types, or is it something specific to effects?
I mean, yeah, the effects can be generic. So you can say, I want to take a function that takes any effect, X, and then I will, use that same effect. Like for instance, map, the map function on lists. It takes a function from A to B that may have any effect E, and it turns a list of A's into a list of B's having that same effect E, because it'll call that effectful function for every element in the list.
Right.
So it'll have that same effect. So it can be generic.
Yeah.
But importantly, the program syntax is no different between effectful code and the regular code.
Yeah.
So like map and traverse are the same function.
That's cool. Yeah, because I've heard the problem related to this described as like colored functions, where I think that the original blog post that talked about this was talking about in JavaScript, which is similar in Kotlin with coroutines, you have to put some additional information on a function, like a suspend fun in Kotlin, or I don't remember what it is in JavaScript or whatever, but that creates two different worlds of functions, those that are async and those that are not. And that makes it so you can't have a single map function, functor or whatever, that knows how to deal with both suspend functions and non-suspend functions. So it creates these, I don't know why they called it colored, but these colored functions that are not interoperable or composable. And that is just about the ability of asynchronicity. But imagine that you have other abilities too. And so I guess one of the amazing things about Unison is that it says, hey, we know it doesn't matter what abilities a function needs, we can deal with that, and the runtime knows how to handle that. Is that all accurate?
Yeah, and as a consequence of this, you don't have to deal with composing monads. Like if you have different abilities, you don't have to worry about how they compose. They always compose in a canonical way. We just like add them to the effect list. And so the issue of like monad transformers and things like that, it doesn't come up in this world.
Yeah. That brings up a question comes up for me about, because you're talking about lists and data structures in general. Like a lot of times there are different implementations for data structures, and you have to know how you're going to use it in order to choose, like, do I have a linked data structure? Do I have some kind of singly, doubly, random access? And it's like, I better know that, so that, how do you deal with that in Unison? Are you able to unify it into, no, just use a list and we'll worry about the details? Is it?
No, you still have those issues of having to choose a representation that matches your users patterns, like for data. But actually, you gave me a good idea, which is that you can do a lot of things abstractly with things like abilities, and so you can do things like simulate stuff. Like, let's say you have this. I don't know. Let's say you have this async ability or like a remote ability, and you call a bunch of these functions and they all do remote stuff. And then let's say you want to like run that using like the most efficient representation possible. then you could, in theory at least, you could run your remote program sort of locally, and then just try to see what it does. Like, for instance, does it actually make any calls across a network boundary?
Hmm.
And if it doesn't, then you can implement it using just like a local, just using the local virtual machine.
Yeah.
And you might be able to like store that as metadata on the hash, saying like, okay, well, given this function, given this hash, like what is actually the most efficient implementation of the ability that it uses, and then you can swap them in and out based on like which hashes you're calling. So all kinds of stuff like that becomes possible because, everything is indexed by hash. Everything is kind of like repeatable.
Mm-hmm. It seems like we as a programming industry keep inching very slowly towards making it so the developer doesn't have to think about resource constraints, whether those are CPUs or memory or whatever. And Unison, I think, takes us a leap forward in that idea of, all right, as a developer, you shouldn't have to think about the most efficient way to do this kind of thing, or where you should run this thing, or if you're going to overflow the memory or whatever. It seems like there are now some new tools that we have to make that like resource, not having to be resource aware in our programming languages. So.
Yeah, and if you could, do what you're talking about, it seems like there could be some device that would automatically try different representations for, because we're bad at guessing when it comes to performance. And so if the machine says, oh, I'll try this kind of list or this kind of list or this kind of list, it turns out the one you wouldn't guess would be the most efficient actually is.
Yeah. And often in production,
yeah,
the amount of data that we're dealing with is very different from what we deal with in our local,
what our
assumptions are.
Yeah.
Yeah, I think that's the kind of thing that content addressed code like unlocks. You can do all kinds of like analyses, and you can basically like build up a knowledge base of things that you know about a hash, and that could afford you some optimizations. So that's a cool idea, I think.
And even have some like AI start to learn what.
Well,
oh my gosh!
Oh, what is that?
Yeah, that sounds awesome. We're really only scratching the surface of like what we can do, and like how much the developer experience changes once you are no longer just like dealing with these big buckets of text files that you're like repeatedly building.
Yeah.
Right.
Yeah, it's like you haven't discovered all the doors that have been unlocked yet.
No, definitely not. We're still discovering stuff.
But I also, there's something in the back of my mind that keeps going back to that. You said something early on where you said, oh, you could actually program in a representation that's more familiar to you, in a language that's more familiar to you. And I think, wow, that could make a transition really easy.
Yeah,
right?
we wouldn't be the first people to do that. Microsoft has done that with their what's it called, .NET, where
Sure.
you could program in F# or C# or Visual Basic or whatever, and you can.
That took a monumental amount of work, though, to create those like different language interfaces.
Often run into, oh, actually, you can't do this thing because you're working with this language, and that's a different language. But another example is sort of C++, where it's like, oh, you can come in as a C programmer and then start adding to what you already know. That transition, I don't know, that was very powerful in the case of C++.
Yeah, for Unison, even though you might have a surface syntax that like looks like Pascal or something, Unison will never be Pascal. Like
Sure.
we can't write Unison compatible Pascal.
But as a
it would
way
be
to
fun
get
to
started, it's like, okay, if I'm able to start, by writing some code in Python, and then I can see what the Haskell code looks like, then for me, that would be like,
as a
I
tool.
see, I do this and it produces this, and now I can start making connections.
So it's a tool for you
for learning,
be able to visualize a given function in different languages,
right?
As a way to,
and then I would be able
to
move to the Haskell representation or whatever more easily, because I could see, all right, this is what it means in my language versus their language.
There's been blog posts that do this to help bridge gaps. But what if it's the tool that is actually doing it?
So anything
on any
you
code
write,
base.
you go, I want to do this, and it goes, here's what it looks like. Well, that would be very powerful.
I mean,
why does it even matter what language you write in? Like it doesn't even matter anymore. Like if you want to write in a Python style, great, write in a Python style.
Yeah, the surface syntax didn't really matter.
And see it as Scala, something like Scala.
But ideally, we would want to have some kind of graphical IDE, for Unison, where like you're interacting with it, kind of like a small talk environment, where you might be able to take some code that's in your code base and just roll in your mouse wheel or something. You'll be able to flip through different syntaxes for it.
Wow!
So that would be pretty cool.
That would be really something.
Yeah. You mentioned YAML and how terrible it is, and yeah, I'm with you on that. But I think it's actually like all DSLs are terrible, or all declarative languages are terrible.
I think it's more that it's not. I don't want to hate on YAML because like that, it's fine and good, but it's really that it's not a programming language.
Yeah, it's. I just tweeted about Getz's law. Remember, Getz's law is that all declarative languages slowly slide towards being terrible general purpose languages or something. So
the same experience that I had with, Make. They kept adding things, and then at some point I think they realized, we're trying to create a programming language here. We need to stop.
So I'm curious your take on Unison and declarative syntax and maybe DAL. I don't know if you've looked at DAL or something that takes a more functional approach, but.
I'm embarrassed to say I actually have not looked at DAL, but
I've only looked at the syntax and it looks interesting, but I haven't actually used it.
Yeah, overall, I think my take on things like that is that I really want to put those things under programmer control. So, rather than like having a deployment that's described declaratively, and then that gets like interpreted by something that like actually does the thing. Just have the machine that your program is running on capable of doing those things, and then put that under programmer control.
Yeah.
It's just like with anything else. It's like I don't know. Like imagine if like how to run your program on multiple CPUs on your machine were under the control of some kind of declarative language that were like it was like out of band, rather than being able to say like, okay, well, new thread.
For a lot of programming environments, it is kind of a different thing. It's like, okay, here's how I normally program, and now if I'm thinking about concurrency, I have to do a whole different. I open a door into a whole different world.
Yeah.
Oh, I mean, effects are like this in Scala or Haskell. Like once you start working with effects, it's like now you're in monads, and the whole syntax is different. It's a completely different way of programming.
Yeah.
Right, and it would be nice if that wasn't the case.
Yeah, would be nice. Yeah, so what if, like you've done with abilities and effects, doing the same thing with declarative, the ability for someone to essentially control another system in a constrained way, but doing it through Unison instead of having to use some weird language that then gets interpreted and then gets...
it's like build systems. It's like, here's what I want to do, and now I have to go to Gradle and learn a whole bunch of other things that don't make sense. Wouldn't it be nice if I could this is why people, said, I want to program in JavaScript on the server as well as on the client, because I don't want to have to learn all these other things. It's like, maybe JavaScript isn't the best, the most ideal way to solve that problem, but I get the motivation.
Yeah.
It's like, I don't want to have to juggle too many languages.
Yeah.
Mm-hmm.
Yeah, and I'm imagining a future where, like, we'll be able to, instead of communicating with an airline or something, by like calling them on the phone and like giving them credit card numbers and stuff like that, you'll just have a Unison hash that will get you the tickets that you want, and you just send them that hash and you say, hey, run this, and they'll say like, oh yeah, that's a perfectly fine hash that we've seen before and we know is safe to run or whatever. It doesn't use any abilities that we don't want to give you, and then they just execute it, and voila, you have your tickets like on chain or whatever.
Yeah.
Like
whole new world of distributed systems.
Yeah, wanted to move towards like a distributed computational internet where instead of everything being like web forms or whatever, it's you're talking to each other. Systems are talking to each other programmatically.
Yeah. Instead of through protocols, it kind of takes the whole idea of a protocol and says, "Nah, we don't need that."
So this is just kind of an idea that popped into my head. Will Unison help with all the problems that blockchain stuff is producing, especially like, ruining the environment because of all the unnecessary computation that's going on?
I don't know about that.
Uh-huh.
I mean,
well, that could be your killer app right there.
Right. The better blockchain.
We're certainly hoping to reduce the waste heat produced by like running builds.
Yeah, for sure.
I don't know. I mean, it seems like there's a lot of excess stuff being done, and also just like a lot of excess work being done, like designing and implementing protocols, and like interfaces between systems, interfaces between microservices, and things like that. So yeah, just like reducing a lot of that waste. I don't know if we're gonna like save the world with this or anything, but
so I think that's going to be a team effort. I think everybody's going to have to get involved with that.
So there's like serverless tagline, which is like not having to make my word to describe it, or maybe I took this from a woman, Yana, I can't remember who invented it, but serverless is make servers somebody else's problem. Stateless is make state somebody else's problem. So the world of Unison is protocol-less, where you make protocols somebody else's problem. Like you actually like make it like maybe it's not protocol-less because the problem just goes away because you don't need protocols anymore. But the world of Unison, protocol-less.
Well, no, you do still need a protocol. The protocol
is Unison
Internet protocol. Right?
Yeah.
So that's something we're designing currently. But yeah, ultimately within this world,
the program is the protocol.
The program is the protocol, right?
Yeah.
You just need to know how to read Unison programs and then execute them.
That's pretty game changing.
Yeah.
Cool. Well, it was super fun to chat with you about Unison. I love how you're changing the foundations to open up whole new worlds of possibility and making things easier in so many ways. And I think it's such an inspiration because we don't often reevaluate the foundations that we've built all these very tippy, unstable, massive structures on top of.
We just get stuck in them. That's what we do. And we assume that they can't be changed.
And people have other work to do.
Yeah, exactly. It's not surprising, but it's true. We do get stuck, and every once in a while, somebody needs to come along and
take a jackhammer to the foundation
and say, "Wait a minute, let's think about this now," rather than just repeating it.
Yeah. Yes. Well, thank you, Rúnar. Really appreciate your time.
Thanks for having me.